Hi everyone. So today we are going to start two pointers and these are the problems we are going to solve. So very first problem is two sum problem and it's very famous problem. I'm taking the second one. You can try after this. You can try two sum one. This is the two-with problem and I'm taking the medium one first because if you understand medium then easy one is very easy. So you can read this problem. So I'm going to explain the question, what it says. So we have given an array, let's say 2, 7, and 11, and 15. So this is the array we have given, and I'm taking the first example. As you can see, this is the example I'm taking, and we also given a target, and in this case, target is 9. Okay, what we have to do, we have to find two numbers. After adding two numbers, we want a target that is 9. Okay, and the elements from the different indices. We want two elements, but they should have different indices. Okay, let me do indexes as well 0, 1, 2, and 3. Okay, so as you can see, this is the two number we have. This is one number and this is one number. If you add this 2 plus 7, you'll get a 9 and which is equal to target. So what we have to do, we have to return the index. What is the index of this? 0 or 1. I think we can return 1 and 0 as well. So I think both are valid if I am correct. Okay. So yes, we can return any of them, like 0, 1 is valid and 1 is 0 valid. Okay, so we just have to find the indices of two numbers. After adding those two numbers, we get a target. So that's the question. How we are going to approach this? A very basic approach. Actually, it has a 3 to 4 approach. We will discuss one by one. And first of all, we will discuss the very brute force approach. So let's do that. So first approach, it's brute force. What we are going to do? So in the question, it is mentioned that we need two elements A plus B, which will give a target. Okay, so what we will do, we will try out all possible numbers A and B for A and B. So how we are going to do, let's say 2, 7 and 11 and 15. Okay, so this is the array we have. I will fix this thing and consider this as a A. Now we have to find a B and we have lot more option. How we are going to try these all the elements, these all the elements have, I'm going to try one by one as a B. So as you can see, A is 2, so 2 plus 7 is 9. Then I'll try, if it is not give the target, then I'll try to next element. It will be 2 plus 11. As you can see, this is 11, so it gives us 13. Then I will try 2 plus 15. 2 plus 15, it will be 17. Although we already get the answer, but if suppose we don't have a target like 9, we have target equal to 20. As you can see, there is no 20 present. So what we have to do, we just increase the A pointer and we will consider this as a A. So now my A is this is A, and we will consider this as a B. Why we are not considering this as a B? Because we already considered na. Uh, this is the thing, like 2 plus 7 is 9, and if you do 7 plus 2 is also 9. So there is no mean to consider this. Okay. Now you can do this. So this is another one. 7 plus what is the b? It is 11 and you'll get 18. Again, it is not the target. So we will try next b. It will be 7 plus 15 and you'll get 3 and 23. So this is the way, and as you can see this is again not getting a target, so we will change a, and now my a is this uh, red color. This is my a now, and we only have one b, so we will consider like this. So let me write it over here. So a is 11, this is a plus b. So a is 11 and b is 15. You'll get 6 and 26. Okay. Now, if you consider a is this, there is no b left. So we will stop here, and this is the brute force approach. Just figure out all possible A and B's and try to find if it is equal to target or not. If it is equal to target, then we will return the indexes of this. Okay, so let me write the pseudocode for it quickly. So it goes like, we need two loops, and it would be let's create a function, and it is accepting a num and the target. Okay, now what we are going to do, we will apply a two loops. So it is for int I equal to 0 up to I is less than n and I plus plus. Okay, so we have to go the second last element, so it would be n minus 1 I plus plus. Okay, then I'm going to do this for int j equal to, I'm going to start from I plus 1, because if I consider this as a, this is as a, then we have to consider b from this one ahead. So this is, let's say this is I, so j starts from here. So j equal to I plus 1 and up to j is less than n, j plus plus. Okay, after doing this, we have to check if my nums of I plus nums of j is equal to target. If it is, then we directly return indexes. So indexed would be I and j. Okay. After the loop ends, if the return statements, if this return statements is not executed, that means there is no pair exist that adding up that gives us target. So what we have to return, we have to return -1, return -1 and -1. Okay, so this is the brute force approach, and this the time complexity it will take, like outer loop taking big O of n, and inner loop is, in a worst case, it also taking big O of n. So it would be, time complexity would be big O of n square, and the space complexity would be big O of 1. Okay, so can we optimize this? Yes, we can optimize this. And whenever you see a problem like this and taking n square and space complexity 1, so you can think of, like in journal case, you can think of like, now the time complexity reduces to big O of n and the space complexity becomes big O of n again. So the way, if you solve many problems, then you can analyze this, like whenever you are trying brute force approach and it's take n square and space 1, so we will expand the space first, then we will. So this is the first optimization we can think of. Okay, so how we are going to use a space to reduce the time complexity? So let's see. So we have a nums. Let me take num. It would be 2, 7, 11, and 15. Okay, and we have target equal to 9. So what we have to find? We have to find two things, a plus b, that gives us target. Okay, if I'll say I know the b, I know the a value, I know a value. So how we will find b? So if I know this thing, this is I know. Suppose I am supposing this. Suppose this I know. Okay. So what we have to find? We have to find b. So how we will find b equal to target minus a. Okay. And target is also known, that is 9. So it would be, this would be b equal to, what is target? My 9 and minus a. A I know. This thing I know. I know. So what we have to find? We have to find only b. That's a easy equation we have. Now let's try how we are going to find. Okay, this is nums. Let me write it once again. It will be 2, 7, 11, and 15. Okay, and my target is 9. And my equation I get is this. This is my equation. I'm going to use this. Okay, so I'm going to traverse from left to right everything, every element I'll go and consider that element is a. So I'll go to this thing, I'll go to this one. Let me take this. I'll go to this, then this, then this, and this. Everything I will consider this as a, this as a, this as a, this as a, and try to figure out b. So how we are going to do that? So let's suppose I am going to index this. Okay, 0, 1, 2, 3. Okay, I am currently at index this, and I am considering this as a. So my a is 2, and I have to find b. So how I will find b? B is going to be 9 minus 2, which is a, and if you do this, 9 minus 2 will be is 7, and you have to find 7 before this index. So there is no element present before this. So what we have to do, we just go to next element. Okay, before going to next element, we will put this thing, this element into some data structure, and we are going to use a map. So this is our map. Okay, this is map, and the first thing is going to represent a value, sorry, value, not value, it would be key, but let's consider its value, and second is going to be index. Okay, after processing the first element, 0th index, I'm going to put the value inside a map. It would be 2, and it has an index 0. After processing this index, go to next index. So my pointer is now pointing to the index 1. So my pointer is pointing to index 1. This is my current pointer. Okay, now this I am considering this is a. Okay, this is a equal to 7, and I have to find b. What is b going to be? 9 minus 7, it is 2, and after getting 2, we have to find b inside a map. This is my map, inside my map, whatever. Let me erase. Okay, inside map, as you can see, 2 is a present. That means we find two elements that gives target after adding. That is a 0th index and the the current index we have. Okay, so we directly return from here that we have find two pairs. So we have to return the index, and index goes like 0 and 1. Okay, suppose this is not our target. What we have to do, we will put this value. Let me erase. I will put this value, the first index, inside a map, and it goes like 7 and it has an index 1. After processing the first index, then I'll move to the next one, and the next index is going to be this, the second, and my current pointer is pointing to this, and I will consider this as a. So my a now is this. My a would be 11, and we have to find b. 9 minus 11, it would be what it would be. Okay, 3, I think, minus 3. Yeah, minus 3. And as you can see, there is no minus 3 present inside map. So what we have to do, we have to put this element inside a map with index. So we're gonna do this. So let me expand this one thing, and okay, this is the map we have, and let's map, and we're gonna put 11 inside this, and this is going to be 11, and index is 2. So we will do the same thing for the all the index. Okay, so this is the approach we are going to use, and yeah, so let's write the code for it. So okay, so we are gonna write a function. So it would be function, it accepts nums and the target. Okay, and in this we need a map, unordered map, unordered map, integer, and integer, let's call it mp. Okay, why I am using unordered map? Because if you use simple map, ordered map, that will take insertion and deletion would take big of log n time complexity. But in unordered map, if you use unordered map, the average time complexity of insertion and deletion would be constant, big O of 1. So that's why we are using unordered map. Okay, so we will go to every index. So it would be for int every index we will consider a. So we will start from a equal to 0. We'll go to a is less than n and a plus plus. Okay, now first of all we have to calculate b. So it would be int b equal to the target. What is target? My target is this, and my a, what is a? So it would be nums of a. Okay, after getting b we have to search in a map. How we will search? If my mp dot find b, if this mp map, if my map contains the b, the process, the way you check is this, is not equal to mp dot end. Okay, if this is present inside my map, so we have to return the index. How we are going to return the index? The index would be return the index. How we will get an index? The value, the second thing, this is the index we have, so it would be mp of b. This will give me a index of the b. Okay, and mp dot end, sorry, the next index would be the current index, so it would be a. So this is what we are going to return after uh, confirming that is the pair. So we will return the index of that two elements. Okay, if we don't find, then we have to put the current element inside a map. So it would be MP of the current element. What is the current element? It would be nums of A. Okay, don't confuse. Let me write it in a different color. So it would be nums of A, and what is the index? And index is this. Okay, so this is the color. Okay, so this is the value of the current index. This is the value of current index, and we are putting that value inside a map and mapping with the index. This is the index. Okay, and that's it. After that, we will return return -1 and -1. That indicates we haven't find any pairs after adding. That gives a target. Okay, so this is the code we have for the second approach. We are using a map, so the time complexity would be big O of n and the space complexity would be big O of n because we are using map, unordered map, ordered map. Okay, so can we reduce the time complexity in terms of space complexity? The time complexity remains the same, big O of n, but the space complexity would be big O of 1, as the question demands also. Like if you read the problem carefully, your solution must use only constant extra space. So how we are going to do that? We will see the third approach for this. Okay, the third approach is this. Let me write it. Third. What we are going to use, it's two pointer approach. Two pointer basically means you have two pointers, like let's say this is an array A, B, C, D, E and F. So you create two pointer according to question. It can be mentioned like two pointer is pointing to this starting thing, then two pointer is pointing to this, and like this. We have to use only two pointers, so that's why we will call it like a two pointers. We can use certainly three pointers as well, because there are the problems also like Dutch national flag. We will going to use three pointers in that, but that doesn't mean that it falls under the category of three pointers, but you get the idea. Like we have to use the pointers. And in this question, how we are going to approach, let's see. And let me take the example that we are taking. So it would be 2, 7, 11 and 15, and my target is 9. Okay, I'm going to create a two pointer. Both pointer are pointing to extremes. Like the first pointer is pointing to this. This is my pointer, and this is pointing, and my another pointer is pointing to here. So this is my left pointer, you can say, and this is my right pointer, you can say. uh, both are pointing to extremes. This, and as you read the problem, in a problem it is mentioned that the array you have given is a sorted means it is increasing order. So the first index, it has a very small value, very small, and the last index has a very large value. So if you add small and large, then we will compare this thing with a target. How we are going to do that? So the my first initialize with this, okay, left and right, sorry. And if you add this elements, so you will get 2. So the first iteration, you can say first, so it would be 2 plus 15. What you will get, 15 or 2, it's 17, and you have to compare it with target. First of all, if my target is equal to 17, which I get this one. No, this is not. If it is equal, then we have to return the index, that is LNR, but it is not equal. Then we have to move the pointer. One of the pointer we have to move. How we are going to do that? We will see if my target 17, 17 is this, 17 is larger, and but my target is this. 17 is very huge, but we have to reduce this to 9. What we have to do? What number you can add so that it becomes lesser? So this is my current situation. This is my current situation. And I want this 9. So I have to reduce this. I have to subtract some value. Okay. By subtracting means we have to decrease the value. How we gonna decrease the value? Since we have added the large number, this is the large number we have added. If I'll reduce this to the next one, if I add this, then you'll get a lesser value than 17. Okay, so we have to reduce the pointer R to the left side, like the R is pointing to this, now it's pointing to this. Why? If you understand this, because we want the smaller value, and for that we have to reduce the larger one. This is the very large number from this array. As you can see, 15 is very large, so we have to reduce this. This is the smallest number we will get. And if you are thinking why we will not increase the left pointer, if you increase this thing, like if you point, now your left pointer is pointing to this. Now if you add 7 plus 15, 7 plus 15, you will get 23, and 23 is a very huge than 17, and 17 is very huge than 9. So you never reach the 9. The possibility of reaching 9 is to move the right pointer. Okay, so this is the way of moving the one of the pointer. According to question, we have to move according to target in this case. Okay, let's move. So it would be, let me erase this. Okay, my right pointer is now pointing to this thing. This is my right pointer, and this is the second iteration. So it would be second. Okay, in this, the left is 2 and the right is 11, and if you add this you'll get 13. But as you compare this with target, 13 is again large than the target. What we have to do then? This is the very large number we are adding. This is the large number we are adding, but we want the small. So we have to move again the right pointer to this side. So my right pointer is now pointing to this. This is my right pointer. Okay, the third iteration, it would be third, and the smallest, the left pointer is 2 and the right pointer is 7. If you add this you'll get a 9, which is equal to 9, and this is the case. You have to return the index, and what is the index? It is left and right. Okay, so this is the approach we are going to follow. Initially, we will point left pointer extreme to the left and the right pointer extreme to the right. Right pointer indicate very large value, left pointer indicate very small value. And if you add this after getting the result of adding, then you should compare, you have to compare with this target, and according to target we have to move one of the pointer to the left or the right. Okay, so this is the way of solving. Okay, let's write a pseudocode right quickly. So it would be function, and nums and the target. Okay, so we need two pointer. Let's initialize this int I, let's call it L, pointing to very extreme to the left, it would be 0, and my right is pointing to very extreme to the right, so it would be n minus 1. Okay, and we have to move until while L is less than or R. Okay, let's say in this case, this is the very large target. 2 7 is my target is now like this. My target is 3. Let's say 3. And if you add this, you will get a 9. 9 is very huge than 3. So we have to decrease the R. So my R is now pointing to this, and R and L are same. But in the question, it is mentioned that you cannot use the same index twice. We need two different indices, two different elements to add, and that will give us target. So we can't do this. We will stop here and we will say we haven't find any two elements that gives us 9 target, or you can say. Okay, so my L is less than R. What we have to do, we just compare if my nums of L plus nums of R equal to target. That means this is my answer. So I'm going to return L and R. Else there is going to be three cases. First case is this, like if it, uh, after adding both the elements, if you get a target equal to target, then we have to return the answer. Else we have to check if my nums of L plus nums of R is greater than target. Then what we have to move? We have to move the right pointer, and the right pointer, moving right pointer means minus minus. Okay, else the only one case is left. That means my this thing is less than target. Okay, so what we have to do? We have to increase the left pointer. So move the left pointer. It would be increasing left pointer. So L plus plus. Okay, after the loop ends, then we have to return minus 1. That indicates there is no elements that gives us a target. Okay, so this is the approach, and if you see the time complexity for this, it would be big O of n, because we are traversing every element at once, and the space complexity would be big O of n. We are not using any space for this solution. Okay, let's just implement quickly on LeetCode. So, and we will try to submit this. Okay, so we need two pointers, which is L. Okay, what? Okay, L equal to 0, and the right is pointing to n minus 1. We need n, so it would be int. Let's do it to array. Let's call it nums. Okay, it would be n equal to nums dot size. Okay, my while loop is L is less than R. What we have to do, let's call it a sum equal to nums of L plus nums of R. Let's call it current sum. Current sum. This is the current sum we have. Now we have to compare this current sum. Current sum equal to target. Then what we have to return? Return L and R, the indexes. Else if my current sum is greater than target, then we have to decrease my right pointer, and else there is only one case, so we have to increase the left pointer. After doing this, if my loop ends, So we have to return -1 and -1. Okay, let's run this and see if it is correct or not. Okay, all the questions, all the answers are incorrect. So what we did wrong here? Let me check. Okay, why we are getting wrong? Uh, Indexes. Okay, so this is zero base indexing and they want one base indexing, so we have to do +1. Okay, so I think now this should be correct. Yeah, all the test cases pass. Let me submit this. And this is submitted. And if you analyze the time complexity, you'll get big O of n. This is big O of n. Okay, so we have solved this question. Now in the next video, we gonna solve Dutch national flag short colors. So we'll try this thing in the next video. Okay, thank you for watching.